Alright, hello and welcome back to Fam Bam. Today's physics topic is dynamics using free body diagrams. So free body diagrams are used to demonstrate the relative magnitude and direction of all forces acting on an object. Magnitude is basically the amount or the number. So 4 newtons to the right tells you how much and in what direction. Alright. The size of the arrow reflects the magnitude of the force. So if you have a small arrow compared to a long arrow, you can tell how much of that force is being applied. So let's say force applied is this long compared to friction. You can tell that something is pulling this object more than friction holding it back. The direction of the arrow reflects the direction of the force being acted. So if the arrow is going this way, force applied is being pulled that way. If you were to push it that way, force applied will be going that way. You must label what type of force acts on the object. So we have force normal, force gravity, also known as force weight, force friction, and force applied. Those are the common ones that you use on a free body diagram. Objects don't necessarily have 4 forces acting on them all the time. It's important to know the different types. So just a few. Force frictional is the force being applied by friction. Gravitational is the force being used by gravity. Force normal is whatever mass the object has. Force applied is anything like a push or a pull. Force tension is usually used when there's pulleys. So there's tension on the rope. So we can draw like on a pulley. We have another object right here. There's tension going on both sides from the pulley and from the object of the rope. Alright. And we also have force spring, which is whenever you have a spring constant and the object is being pushed, there's a force being done on the spring. And also, if you were to release it, the object will go this way, and the spring will also have a force impacting the object pushing that way. You must remember that it's always equal but opposite forces are balanced forces. And when there's an extra force acting on it, it's an unbalanced force. There isn't any equation for these topics, but you just have to practice the different types of free body diagrams. So we have a few examples over here. A book at a resting position on the tabletop. All right. So the 2 forces that are being used on the object, this would be a box will always represent the object. So a square is the book, and you have force gravity pulling on it, or else the book will float. And you have force normal acting on it. So both of them are equal but opposite, and they help the book stay in place. That's why they don't float or fall through the table. This is an example of a balanced force. Balanced forces, because you have force normal and force gravity canceling each other out to have the object at rest. An egg falling from the nest on a tree. This would represent the egg. And imagine it on a tree. So the only thing that would be acting on it would be force gravity. And this is an example of unbalanced force, because the only force that's acting on it is gravity itself. So last problem is a car is coasting to the right, it's slowing down. So imagine a car right? It's moving to the right. but it's also slowing down, meaning that you are applying your brakes on it. That's what slowing down means. So you have force normal acting on it, which is its mass that holds it down. Gravity, which is pulling it towards the center of the earth so that the car doesn't float at all, it stays on the ground. And your force friction would be the part that is slowing down, because the wheels are causing friction with the road, making it halt, you can say, or begin to slow down. So you're not pressing your accelerator anymore. You are now using your brake, which is to pull back with friction. And that's it. That's all you need to know about free body diagrams. Thanks for watching.